Okay, yeah, hi guys, welcome to the live session. Today we are going to learn one of the most important problem, okay, which is nothing but rotting oranges. Now over here, the thing is that this problem might look very easy at the first, okay, but it introduced one of the uh, important concept in DSA, that is using a queue for BFS, that is breadth first search. Now if you're new to this BFS, okay, just follow along. Okay, I will be explaining step by step. Okay, and let's begin with this problem first, okay, without wasting any time. Now over here, first let's see about the problem statement. So the problem number is 994. Okay, so over here we are giving us n cross m, sorry, m cross n grid, in which 0 represents the empty cell. So basically on that cell no oranges is present. One represents a fresh orange, okay, over there the orange is there, okay, and two represents the rotten oranges. Now every minute any fresh orange that is four directionally adjacent to the rotten oranges become rotten, okay. Now we need to return the minimum number of minutes that must elapse until no cell has the fresh orange at all, okay. But there will be a case that even after reaching in four directional, that is up, right, down, right, sorry, left, okay, we are not able to rot that orange. So at that time we need to return -1. So this is the statement that it is talking about. If it is impossible to rot that orange, then we need to return -1. Okay, now I have taken the I have taken the example from the lead code only. So over here I can see that this orange is rotten, okay. Now in the after the first minute, this orange will rot this orange and this one, okay, after the first minute. So let's rot this will be rotten, okay. So 1 minute has been elapsed now. Now after second minute, this orange will rot this one and this one. Why two? Because we need to move in four directions: up, right, down, left, okay. And for this, if I'm going above, there is no orange. If I go on the right hand side, there is orange, okay. So I'll rot this, okay. And if I for this, if I go below, okay, this is also fresh orange, so I have to rot this as well, okay. And if I go on the left hand side, so this is already rotten, okay. Now talking about this, okay, why? Because this orange got rotted at the first minute, okay, so we need to talk about this as well. Now if I go above, already rotten, this on the right hand side already rotten, on the down there is no orange, and on the left hand side there is nothing at all, okay. So second minute has been elapsed, in which this has already rotten. Now see, after the second minute this has rotten, this two oranges has rotten, okay. Now if I consider this, if I move upward, there is no orange at all. On the right hand side, no. On the downward also there is no, and on the left hand side already orange has been rotten. Now if I talk about this, if I go above, already rotten. On the right hand side no orange, but on the downward side there is a one rotten orange, sorry, there is fresh orange, in which it will rot it, okay. And on the left hand side already rotten, okay. So minute 3 has been elapsed, in which this oranges has been rotten, okay. Now if I'm standing over here, okay, if this is the rotted orange, if I move above, the orange is already rotten. If I go on the right hand side, I can see the fresh orange, I can see the fresh orange, okay. So this will be rotten, okay. And if I go on the above, sorry, below, there is nothing, and on the left hand side also nothing. So minute 4 has been elapsed. I believe that you have understood. Okay, so for this, the 4 minutes is needed to rot all the oranges. Okay, now let's come over here. If I take a look on this, if I take a look on this, on the first minute, this will be rot. Perfect. On the second minute, this orange will rot this one and this one. Okay, so this will be rotten on the second minute. So 2 minutes has been elapsed now. Now on the third minute, this orange will rot this one. Okay, so this will rot, and the time has been elapsed to 3. Now this orange will rot this one. Okay, so this will be rotten. So the time elapsed is 4 minutes now. But I can see that there is no adjacent rotten orange over here that will rot this one. Okay, so after scanning, okay, I can see still that the fresh orange is still there. Okay, so over here I need to return -1 as an answer. Okay, now there is one more edge case that we need to consider. See, over here there is only one rotted orange, which is this, and what is 0 represent? That is no oranges are there. Okay, so for the 0th minute, okay, this is already been rotted. Okay, so after 1 minute also nothing is changed. Okay, so it requires only 0 minute to rot all the oranges. Okay, I believe that you got this edge case. Okay, now this was the example which is there was on a lead code. Now let's have a logic. See, if I take this example, okay, in which here I can see that two oranges are rotted. Okay, so talking about the brute force, what you can do, you can just scan, okay, from the top left to the bottom right corner, okay, and see that which oranges are rotted. If you can see that this orange is rotted, go for the four direction, up, right, bottom, and left, okay, and rot that oranges, okay, and after again you have to do the quick scan, searching for which oranges has been rotted, okay, and for every iteration you will be increasing the minute, okay. So as I told you that we will be just talking about the idea of the brute force, okay, so this is the idea that over there you will be scanning the 2D metrics, okay, for m into n, okay, square times, okay, so this will be the time complexity of brute force approach, okay. Even though if you didn't got it, okay, you can just take some few minutes and try to analyze this, you will for sure get it, okay. Now let's talk about the optimized version. Over there we will be over here we will be using a queue. Now what you can do, see, at the 0th minute these two oranges are rotted, fine. On the first minute this oranges will rot. Why these two? Because this will rot this one and this one for the first minute, and for the same minute only this orange will rot this one. Okay. Now here you can see that after that I need to take this and rot this one and this one. Okay. Now here we are not going by depth, we are going by breadth. How? First take this and this simultaneously and rot this. Okay, then among these four take any of them and draw the adjacent one. Okay, so here you can see that we are going by breadth first search, not depth first search. Okay, and if you want to have the breadth first search approach, okay, over here q will be very helpful for us. Okay, so let me just have q over here, in which first of all what you will do, you will have a quick scan in whole matrix or in the whole grid, searching that which is rotted initially at the 0th minute, which orange is rotted. Now over here in this queue, I will be storing the indexes of the matrix. Okay, stating that if this is 0, let me give the indexes 0, 1, 2, 0, 1, 2. Okay, I will be having a quick scan. So 0 comma 0 is rotted and 2 comma 2 is rotted. Okay, so I will be storing in the queue. Understood? So 0 comma 0 and 2 comma 2. Perfect. Now I will be taking this thing. Okay, I will be taking this thing and I will be traveling on the adjacent four directions. Okay, up, right, bottom, left. Okay, and I'll check that if the adjacent orange is fresh, I will make them rot. Okay, and after making them rot, I will make sure that that is also stored in the queue, so that it will be helpful for the future to rot the another one. Okay, now if I take this, if I take this, just a moment, let me just bring it above. Okay, so 0 comma 0. Now if I want to go above, okay, that means I want to go above the row, so it will be minus 1 comma 0. Same column will be there, but here the thing is that I can't go above because the row index is minus 1, so this is not possible. Okay, then I'll go on the right hand side. Now if I want to go on the right hand side, then I need to increase the column, but the row will be same, so row will be 0 as it is. I want to increase the column, that will be 1. Now I'll take a look, just a moment, let me delete this. Okay, now I will go on the right hand side. Here I can see that it is rotted, sorry, it is fresh. It is fresh, so it will be get rotted in first minute. Okay, now I'll store it over here, which is 0 comma 1. But make sure that you are rotting it as well, because when you're standing over here and when you will be moving on the left hand side, okay, if one is there, so this indexes will again store over here, and we don't want that to happen. Okay, now this is rotted. Now let's move on the downward side. Okay, so I believe that you know that we are increasing the row, so this will be 1 and the column will be same, that is 0. Now for this is the next one, okay, which is 1 comma 0. I can see that it is a fresh orange. Okay, so this has to be rotted. Okay, and make sure that you are putting it over here as well. Okay, and then if I want to move on the left hand side, okay, so for the left hand side, the row will be same, that is 0, but the column will be decremented by minus 1. Okay, now this is not possible. This is not possible because it is out of the boundary. Now here you have successfully stored that for this, which orange will rot. Okay, which is 0 comma 1 and 1 comma 0. Perfect. Now we are not done yet. Why? Because I need to take a look on this as well, so which is 2 comma. Okay, we will be applying the same thing. Take 2 comma 2, go above. Okay, if I want to go above, so the row has to be decremented, 1 comma 2. Now if I go at 1 comma 2, I can see that 1 is there, so I will make them rot and then store it over here as well. So 1 comma 2. Okay, then I want to go on the left, sorry, right hand side. If I go on the right hand side of 2 comma 2, the row will be same, but the column will be incremented by 1. That this is not possible. Okay, out of the boundary. Now I need to go on the bottom side. So for the bottom side, the row has to be incremented by 1. So 3, and the column will be same, that is 2. This is also not possible. Now if I go on the left hand side, over here, the row will be same, but the column will be decremented by 1, which will be 2 minus 1 will be 1. Now I need to take a look on 2 minus 2 comma 1. 2 comma 1 is 1. Okay, so I will make this rot and store it over here as 2 comma 1. Perfect. Now 1 minute has been elapsed and we have seen this 2. Okay, so increment, initially the minute will be 0, now it will be incremented to 1. Okay, now what I'll do, I'll take this into consideration and I'll find that which adjacent oranges are not rotten or fresh. Okay, if it is fresh, I will make them rot. Now I'll delete this and let me delete this as well. Okay, now let's take a look on this, which is this one. Okay, I'll apply the same thing. I'll take 0 comma 1. I will be moving up above. Okay, if I want to move above, So the row will be decremented by 1. Okay, so it will be minus 1 comma 0. This is not possible, we know that. Now if I go on the right hand side, okay, the row will be same, that will be 0, but the column will be incremented by 1, that is 2. Okay, now if I go on this side, I can see that this is 1. Okay, so I will make them rot. Okay, first rot it and then put it over here, that is 0 comma 2. Now I want to go on the downward side. So for the downward side, the row has to be incremented by 1. So 0 will become 1 and the column will be same. Okay. Now if I take a look on 1 comma 1, I can see that it is a fresh orange. It is a fresh orange. Okay. So I will make this rot and store it over here as well. 1 comma 1. Perfect. And I'll go on the left hand side. Now for 0 comma 1, if I want to go on the left hand side, the row will be same, but the column will be decremented by 1. So it will be 0. Perfect. Now if I go on the left hand side, okay, since I'm standing over here, the thing is that this orange is already rotted. So I'll not consider this. I'll not consider this. Okay. Understood? I have only considered two things, this one and this one, which I have already stored it. Perfect. Now I need to consider this. Okay, guys. Again, I believe that you are getting that this is happening simultaneously. Okay, parallelly this is happening. As we know that this oranges has rotted two oranges. This one, and this one at the same time. Okay, so this will also rot it. Its adjacent oranges at the same time only. Okay, now let's consider this one. 1 comma 0. Okay, now I will be very quick. See, I'm standing at 1 comma 0, which is this. If I go above, it is already rotted. If I go on the right hand side, it is already rotted. But if I go on the downward side, okay, this is not rotted. Okay, so I'll rot that. Perfect. And I'll store it over here. So 2 comma 0. Perfect. Now I'll go on the left hand side. And when I'm going on the left hand side, it is out of the boundary. Okay, so I'll not consider this. Perfect. So this is also done. Now I'll have this one. Okay. Now for 1 comma 2, 1 comma 2 is this, right? Yeah. If I go above, it is rotted. If I go on the right hand side, out of the boundary. If I go below, already rotted. If I go on the left hand side, already rotted. Okay. So this is also done. Now let's talk about this one, 2 comma 1, which is this. Yeah, I'm so sorry. Which is this. Okay. Now if I go above, already rotted. If I go on the right hand side, already rotted. If I go below, out of the boundary. If I go left hand side, already rotted. So this is also done. Okay, and 2 minutes have been elapsed. Perfect. Now let's talk about this one. Okay, for 0 comma 2 or 0 2 at this one. If I go above, out of boundary, on the right hand side, out of boundary, on the downward, already rotted, on the left side also already rotted. So this is also done. And the same thing you can see for the 1 comma 1 also, all the four directional adjacent are already rotted. So this is also done. This is also done. For 2 comma 1 also you can see that 2 comma 0, sorry, 2 comma 0 above already rotted, on the right hand side already rotted, downward out of the boundary, on the left side out of the boundary. Okay, so 3 minutes has been elapsed. So basically it will take minimum 3 minutes to rot the whole orange thing. I believe you got it. Okay, now let's have a pseudocode. Now the question arises that how you are going to store this in a form of a pair. Okay, so what you can do, you can just create one class. Okay, in that class you will be storing two elements, I and G. Okay, so whenever you want to store any element, okay, you will be calling the constructor of that pair class and you will be storing it over here. This is the first point. Okay, now the second point is that how many times I need to iterate. See guys, for this I have taken all the things one by one. Okay, and over here 1 minute has been elapsed. Over here also 1 minute has been elapsed. Over over here also 1 minute has been elapsed. So one, one overall it is 3. So when you are storing it now, you are also calculating the size, and for that many iteration only you are deleting this. Okay, so when you are standing over here, you have basically stored this much pair. Okay, so what is the size of this queue now? 4. Okay, so you will be iterating 4 times, and you will be taking one by one. That means you will be pulling or deleting one by one, and you are exploring the 4 directional adjacent oranges. Okay, and you are storing it over here. I believe you got it. If you didn't, just wait. Okay, in the pseudocode, it will be clear. This is the second point. Now the question arises that how you are going to move in the directional. That means up, right, down, left. Okay. What you can do, you can just create two arrays. This is for y. Sorry, this is for x, and this is for y. Direction x and direction y. Now over here, let's see if I have 1 comma 0. Okay, if I want to move upward, over here the row will be decremented. The row will be decremented, but the column will be same. So you will have -1 and 0. Okay, now if you want to move on the right hand side, over here the row will be same, but the column will be incremented to 1. So you will have 0 comma 1. Perfect. Just bear with me, I will explain you. Okay, now if you want to move on the downward side, over here, the column will be same, but the row will be incremented. Row will be incremented. That will be 2. So this will be 1, and this will be 0. Okay, and next we need to move on the left hand side. Over here, the row will be same, which will be 1, and the column will be decremented. That is -1. Okay, decremented. So you will have 0 and here -1. Now, basically, what you will do, you will have these indices and you will be doing addition of these two. So, one, the row will be added over here, and the column index will be added with this. Okay. So, if I want to find the downward side, which is this. Okay. What I'll do, I'll just take one and add it with this. So, you will be getting 2. Take this and add it with this, so you will be getting 0, which is this. Okay, so these are the 3 points that I would like to tell you. Now let's talk about the pseudocode. As I told you that first we will be going to have the class. Okay, so class, the name of the class will be pair, in which it will have 2 points, I and j. Okay, now we will be going to have a constructor. So pair int I comma int j. Now if you know about the oops concept, you should be knowing this. So this dot I equals to I. This dot j equals to j, and that's it. We are done for this class. Okay, so when we want to store the indices I and j, we will be calling this constructor, in which I and j will be passed, and that will be stored over here. Okay, now let me first delete this. Now see, first thing that we need to traverse on the whole matrix, just to find just to find that which oranges are rotted already at the 0th minute. Okay, now for that, before that, I just need to have some variables. First, int n, which will be grid dot length. This will give me the row. Then m will be grid of 0 dot length. This will be give me number of columns. Okay, now we will be going to have the direction x and direction y array. So int dirx equals to, so for the direction x, first we need to move upward. Okay, so it will be minus 1 0 1 0, and same for direction y. Over here, since we are going to move upward, so this will be 0, the column will not change. But when you want to move on the right hand side, over that the column will be changed, so you will be adding 1 to it, and this will be 0, this will be minus 1. Okay, now why this is? Because here I'm going in this way: first up, then right, then down, and then left. Okay, this is the thing. That's the reason I have taken this. Now if you want to change this, then this matrix will also be changed. Okay, this array will also get changed. Now after having this, let's have minute will be initially 0. Okay, this is a minute, not minimum. Now I will be having the traversal. So for I equals to 0 to n, then for j equals to 0 to m. Perfect. Now if array, or just a moment, grid, not array, grid of I comma j, if it is 2, that means it is rotted, so we need to store that in the queue. So queue dot add, here I'm going to store in a pair. Okay, so I will be calling the constructor now, new pair, in which I will be passing I and j. That's it, we are done for this. So this is the first thing. Okay, now after this, what we are basically doing, see, at the first go, it will 0 comma 0 and 2 comma 2 will be stored. Now you will be taking this and exploring the four direction, then taking this and exploring the four direction, and after that you will be incrementing the minute. Okay, so you need to find the size of the queue. Okay, you need to find the size of the queue. So there will be a while. Now what should be the condition of the while? I'll tell you just in a minute. Okay, now in this you will have int size, which will be q dot size. Okay, then you will be having a boolean that says rotted. Initially it will be false. Why this is? Because there will be a time, what if, see guys, over here, when I was exploring this, when I was exploring this, I can see that all the things were rotted. All the things were rotted. So why to waste on time in this? Why to waste on time in this? Just increment a minute and return the answer. Okay, because everything is rotted. So even if I explore this one, no point. Even if I explore this one, no point. Not for this as well. So due to that reason, I have taken one boolean flag, in which initially if it is false. Okay. Now I will be having for. So for, or let's have d, or let's have x equals to 1, x is less than equals to size, x plus plus. Okay, now first we need to poll it, we need to remove it. So pair p equals to q dot poll. Okay, so we are removing this first. What is there at the front? We are removing this. Now taking this and then exploring all the directions. Okay, all the four directions. So take this, then have int new x equals to p dot I. Okay, int new y equals to p dot j. I believe you should be knowing this. I've done nothing. I've just extracted the ith index and given new x, extracted the jth index and gave the name as new y. Okay, now for Let's have d equals to 0. D is less than 4, d plus plus. Now why d is less than 4? Because we just need to iterate 4 times. Why? Because we need to move in 4 directions. Okay. Now first I will be moving on the above. Now before moving above, you need to also consider that it is not out of the boundary. Okay. If nx should be greater than 0 and nx should be lesser than n. This is the first. Second will be ny should be greater than 0 and ny should be lesser than m. Also, you need to also make sure that since you are exploring the 4 directions, you also need to make sure that it is fresh. It is fresh. Okay, then only it will be rotted. So grade of nx ny should be equals to 1. If it is, if this is the case, then okay, let me put it over here so that it will be visible for you. Okay, don't worry, then we will assemble it. Now, if that's the case, then you need to make that cell as rotted. Okay, so grid of nx ny equals to 2. Okay, so it will be rotted, and you need to put that in the queue as well. So queue dot add new pair, and over here you need to pass nx comma ny, and that's it, we are done. So let me make this clear so that it will be not confused you. Perfect. Okay, now since you are making this, since you are rotting it, okay, but don't forget to mark that flag as true because you have rotted the orange. So rotted equals to true. That's it. Okay, so I believe you got it now. Now, after this, after polling everything or after removing everything from the queue, okay, you have explored all the 4 directions. Okay, now you will check that is rotted done, is rotted done. If it is not done, then there is a no point of having the another one as the or exploring the another one. So this will be very helpful. So if it is rotted, then increment the minute. Okay, and that's it, we are done for this. Okay, now the question arises, what should present over here? Now see guys, for how long we are doing it? Okay, we are exploring everything. Okay, and here I have stopped it. Here I have stopped it. Why? Because this was not able to put anything over here. This also not able to put anything over here because everything was rotted, and this also was not able to put everything here. So you have to end it over here, right? And when it will happen, when the queue will become empty, because when we are exploring this, we are removing it. When we are exploring this, we are removing it. When we are exploring this, then we are removing it. Okay, so at last nothing will be there. Okay, so you need to make sure that queue dot size should be greater than 0. If it is equals to 0, then you will come out of that while loop. Okay, now there is one more trick that you need to make sure. See, there will be a point when even after exploring everything, okay, if at least one orange is not rotted, it is because you are not able to go in that position. Okay, so you need to return -1 at that time. So for I equals to 0 to n, for j equals to 0 to m. Okay, if grid of I comma j is equals to 1, it means that it is not rotted, so you need to return -1. That's, don't need to go further, just return -1 and come out of the problem. I believe that you have understood this. Okay, now at last you can just return minute. Okay, so that's it, that's what that is, what is was. Okay, so I believe you got this whole thing. Now first you are going to create the class, then you will be going to declare some variables, and this will be the first point. This will be the first point to check whether which oranges are rotten. Okay, after doing that, this will be the next point. Okay, and then you will be going to have this to check whether, even after exploring all the oranges, is there any orange left in which it is still not rotted, then you need to return -1. That's it. Okay, I believe you got it. Now just a moment, let me check if you have any questions. Okay, anybody wants to ask any questions? Okay, fine then. So now this brings us to the end of this problem. Okay, now the thing is that if you have understood this problem actually, that how DFX work using the queue, you have not just understood one problem. The same idea of processing level by level appears in almost more patterns, like related to the grid or related to the graph, or even finding the shortest path. Okay, so if this session helped you understand the queue in a better way, make sure you like the video and share it with your friends who are struggling with DSA as well. And if you don't want to miss any upcoming live session or any DSA question, make sure you subscribe to Algo Exploration as well. So I thank you so much for watching till the end and also participating in the live session. So that's it from my side. I'll see you in the next session. Till then, keep practicing. Okay. So I'm since you guys have no questions, so I'm ending the stream now.